PU2 aspirants, a very good morning to all of you. So today we are going to write our chemistry final PU2 exam, and I know that all of you have already woken up for the final revision. So in this video I am going to tell you all the key topics that you need to revise before the exam. I'll try to keep this video within 30 minutes so that you can just know what all topics you have to revise them and then go for your exams. Okay, so now basically you will see the first thing that we are going to discuss is from the solutions chapter. So first of all, the first question here is a small mistake. This is Raoult's law. Okay, so we have here Raoult's law, and what is the Raoult's law? Raoult's law is, it states that in a solution of two volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction. How can we mathematically determine it? P of the A is equal to P naught A into XA. This is your Raoult's law. Okay. Next, moving to Henry's law, mathematical term, significance of KH and the application of Henry's law. So here you can see, first of all, Henry's law states that the solubility of a gas is directly proportional to the partial pressure of the gas present above the solution. Then you have P is equal to KH into X. What is the mole fraction? What is the significance of this KH? Higher the KH value, lower is the solubility. Next you have applications of Henry's law. So it is used in the preparation of carbonated drinks, it is used by scuba divers, it is used at higher altitude, the medical condition that is anoxia. Okay. Next, moving to ideal and non-ideal solutions. So difference between ideal and non-ideal solutions, and you should also be learning about their examples. So quickly revise their examples. For example, here we have hexane and heptane. So N-hexane plus N-heptane. Okay. Here you can write any example. For example, I can write CHCl3 plus acetone. Okay, positive, negative, any deviation you can write down. Ideal and non-ideal. Apart from this, also revise positive and negative deviation. Their differences also you should prepare. Next, going to isotropic mixture. So binary liquid mixtures having the same composition in the liquid and in the vapor phase and boil at a constant temperature is called as isotropic mixture. Example, you have 95% ethanol and 5% water, 68% and 32% nitric acid solution is also the example. And then you have to write the types of isotropic mixture, that is maximum and minimum, and their difference is given here. So please practice this one, maximum and minimum boiling isotope difference. Okay. Next we have here all the formulas of colligative properties. So relative lowering of vapor pressure, then you have elevation in boiling point, depression. So this is the same thing. Okay, so when the solution is diluted, we do not consider this number of moles of solute. Okay, then this is depression in freezing point, and this is your osmotic pressure. Okay, after that we will okay, next is your what is osmotic pressure, give equation, and what is reverse osmosis. So what is osmotic pressure? The external pressure applied on the concentrated solution to stop osmosis is called as osmotic pressure. What is the expression? I have already given. Pi is equal to C into R into T. C is concentration, R is gas constant, T is temperature, and it should be in Kelvin. R value should be 0.083 liter ATM, right? Mole inverse and Kelvin inverse. Okay. Next is when a pressure more than the osmotic pressure is applied to a concentrated solution, the solvent flows from the concentrated solution to the dilute solution through a semi-permeable membrane. This phenomenon is called as your reverse osmosis. Next, the three reasons why osmotic pressure is the better way to calculate the molar masses of macromolecules. The first thing, it uses molarity, it is calculated at room temperature, and the next thing is the magnitude is very large as compared to other colligative properties. Next, desalination of water or the application of reverse osmosis. So you can write down that when you apply a pressure more than the osmotic pressure on the seawater, pure water is squeezed out from this, and this is what is reverse osmosis used in the desalination process, and the membrane used here is cellulose acetate. So yes, this diagram you can do. Next, moving to kinetics. So first is what is the main criteria for effective collisions, and according to the simple collision theory, so they should have proper activation energy and the proper orientation. Okay, these are the two criteria for effective collision. Next, integrated rate equation for zeroth order, zeroth order. This derivation is very important. Please prepare this derivation, and always do not forget to use R and P. Do not use A gives you B plus C. Okay, that will not be counted. You have to use R where gives you P. Next, we have integrated rate equation for first order. The same thing here, derivation please prepare. Here also you should use R gives P. Okay, do not write A gives B plus C. Next, we have here integrated rate equation for first order gas phase reaction. So I am just writing you the definition, like how to derive it. See, A gives B plus C. In this particular derivation you can use A, B and C. That is fine. So let the initial pressure be P. This is 0, this is 0. Let X amount of A, so this is at time equal to 0, this is at time equal to T. X amount of A has reacted, so XX will form here. Then I can write P total is how much? This, if I add all this, I will get Pi plus X. Then what is X value? X value is Pt minus Pi, right? So what is the pressure of A? Or I can write final pressure of A will be Pi minus X, or that is Pi minus Pt minus Pi. So that will give me 2 Pi minus Pt. Right. Now what is the value of K here for first order equation? 2.303 by T log of A naught. Sorry. So please mention R naught, not R naught, because we are using pressure, right? So it has to be P initial by P final. So it is 2.303 by T log of Pi value will be your Pi, and P final we have found out it is 2 Pi minus Pt. So other things you should write, like let us assume that this reaction is considered, let Pi be the initial pressure. So these all terms you have to write, and then you have to do this derivation. Next, I also want to mention here two more formulas. Half-life. Half-life for zeroth order is that is A naught by, or I can write R naught by 2K, right? And for first order it is T half is equal to 0.693 by K. I have given you the formula video yesterday evening. You can prepare, just go through that and prepare all the formulas. PDF is already there, so no need to watch the video. Go to the WhatsApp channel, download the PDF and just see all the formulas. Okay, next, what is collision frequency and drawbacks of collision frequency? First of all, the number of collisions taking place per second per unit volume is collision frequency. It is denoted as ZAB. Okay. Drawbacks, it considers the molecules to be hard spheres. Okay, it doesn't consider their original structure. It considers the molecules to be hard spheres. And next one here is, it only considers the kinetic energy of the molecule and no other energy is considered. Okay. Next, Arrhenius equation and all the terms. K is equal to A into e to the power of minus Ea by RT. Explain all the terms here, and here also you should be remembering this formula, very useful formula. Log K2 by K1 is equal to Ea by 2.303 R into T2 minus T1 by T1 into T2. This formula is used to calculate the activation energy. What is the R value here? 8.314 joule mole inverse Kelvin inverse. Okay, and one thing, temperature should be in Kelvin. Okay, now many students have asked me that, I have seen a comment that whether the time that you include in the zeroth order, first order, it should be in minutes or seconds. So in the question, if it is not mentioned what should be the unit of time, then you can take any unit. For example, if it is the mention in the question that calculate the rate constant in seconds or in minutes, then you should give that particular unit. If it is not mentioned, you can do in any units. Okay. Next, explain the effect of catalyst. So catalyst, what does it? It increases the rate of the reaction by decreasing the activation energy, right? So draw this graph, and this is the thing. Next, effect of temperature. Okay, so you can have direct question that draw the plot the Maxwell-Boltzmann distribution curve or there can be a question like use energy distribution curve showing the temperature dependence of the rate of the reaction, means how the rate is dependent on the temperature, that you have to show. So when you draw this graph, you have to show that when the temperature is T, the number of particles having energy greater than the threshold energy is less. Now when you increase the temperature, the number of particles having energy greater than the threshold energy is much more, so that is why as the number of particles increases, the rate of the reaction will increase. Okay. Next we have Arrhenius theory. This is important question. So Arrhenius theory says that directly reactants does not get converted to products, it first gets converted to an activated complex. Now this activated complex gets converted to the product form, right? So here you have to give an example. If it is asked by using the energy level diagram, you can take the example of H2 and I2. So first H2 and I2 react to give you an activated complex like this, and then this one will give you the product. And how can we draw the diagram? See, H2 plus I2 is there, then we have got an activated complex here, then it is converted to HI. Okay, next moving to electrochemistry. So this is important question. Direct measurement by Wheatstone bridge is not possible. The two reasons why it is not possible is your direct current, and you cannot connect wires to an electrolyte, to a liquid solution, right? So to solve this problem, we can use alternating current and the electrolyte whose conductance you want to measure, that you can take in the conductivity cell, and that conductivity cell is connected to the Wheatstone bridge. Okay. Next we have Faraday's first law and second law. The statements you should revise all the statements, Faraday's first law, second law statement, their mathematical formula as well you should be revising. Okay. So next we have here, yes, the factors on which different things depends. The first thing here is electrode potential or EMF of the cell. It depends on concentration, temperature and the type of electrode. Next, if you have metallic conductance, this is not that important. Ionic conductance is important. All the 5 factors are given here. Next, you have product of electrolysis. This is also an important question. Okay. So the factors on which these two things depend, that you should be knowing. Next we have dry cell. So dry cell is your reaction of anode and cathode. Zinc is here anode, MnO2 is the cathode with ammonia. So what is the role of produced ammonia? It forms complex with this Zn2 plus. Okay, ammonia produced in the reaction forms a complex with Zn2 plus to give you ZnNH3 whole 4 2 plus. Okay. Next, SHE. This is very important question, right? Standard hydrogen electrode, its construction, you have a platinum foil, it is covered with finely divided platinum, then it is having a platinum wire, it is connected to mercury, then you have a copper wire for the external circuit. Now this whole setup is dipped in a 1 molar HCl solution. How can you show that? This is how you can show that. And then what happens? Write the reaction and the symbolic notation. So you can see the reaction, H plus electron gives you half H2, that is the reaction, and the symbol is platinum H2 bar then H plus. Okay. And this SHE volt is considered to be 0 volt. Okay, this also you should be knowing. Next we have H2O2 fuel cell. This diagram is very important. Very simple diagram, but mark it properly. Here you can write down aqueous NaOH. Electrolyte is given, basically it is NaOH. Okay, and then you also should be writing the anode and cathode reaction. Okay, this is important. Anode and cathode reaction you have to remember. Please practice it again and again and then go for the exam. Okay, next is effect of dilution and conductivity and molar conductivity. So conductivity will decrease, molar conductivity will increase. Okay, so conductivity is basically the conduction of ions per unit volume. So when you dilute it, the number of ions per unit volume will decrease, so conductivity will decrease, molar conductivity will increase. Okay, then here also I want to draw one graph, molar conductivity with relation to the concentration, okay, for strong electrolyte and for weak electrolyte. For strong electrolyte it is a straight line, for weak electrolyte it is a curved line. Okay. Next we have lead battery. So this is important, reaction at anode and cathode and the overall reaction. It will be little difficult to remember, but yes, please write down at least 3-4 times and practice it. So this is for discharging. Okay, What will be the reaction for recharging? Just the reverse of this one. Okay, reverse will be your recharging reaction. Okay. Next we have Kohlrausch law and its application. So the statement of Kohlrausch law that the molar conductance of an electrolyte at infinite dilution is equal to the sum of the ionic conductance of the respective cations and anions of the electrolyte. What are its application? It is used to calculate the molar conductivity of weak electrolyte, and it is used to calculate the the acid dissociation constant, right? Sorry, not extent of dissociation, we use this formula, molar conductivity by limiting molar conductivity. What's the formula of molar conductivity? Kappa into 1000 by C. Okay, so these some formulas you should be knowing. Next we'll go to D and F block. Study of actinoids is very difficult. Why? Because actinoids are having very less short half-life, they are produced in nanograms and they are highly radioactive. Then catalytic property, this is very important question. At least 3 properties you should be knowing why it can be used as a catalyst. Other than that, you should also be knowing what is interstitial compounds, why it can form complex compounds. Okay, please include these two. These two also you should revise. Okay, why transition elements can form complex compounds, why transition elements can form interstitial compounds, or what are interstitial compounds and their properties. Coming to catalytic property, it is because they have empty d orbital, they have various variable oxidation state, and they can form complex with with other substances. Okay, so that is there 3 points. An example, vanadium pentoxide is used in contact process, that is your manufacture of H2SO4. Next, this is very important question again, lanthanide contraction, consequences of lanthanide contraction, and we have reason of lanthanide contraction, cause. So steady decrease along the period in the sizes is lanthanide contraction. The reason is poor shielding effect of 4f orbitals, and the applications or the consequences is zirconium and hafnium has similar size, because of which their properties are similar, because of which they cannot be separated. And then basicity. Next, potassium dichromate preparation. Please remember all the 3 steps with balancing. Okay, balancing is mandatory. You should be knowing here how can we balance the equation. Similarly, KMnO4, how is KMnO4 manufactured? Balancing also important. So please learn these 2 reactions. Next, difference between actinoids and lanthanoids. So directly this question may not be asked, but it can be like write 3 properties of lanthanoids or write 3 properties of actinoids. In that case, you should be using this table. Okay, just remember any 3 points. Next, mic metal composition is very important. Lanthanide is 95%, iron is 5%, and other elements. And then mic metal is used in magnesium based alloy to produce bullets, shell, and lighter flint. Okay. Next, we have how to calculate the magnetic moment. So mu is equal to root over of n into n plus 2, where n is number of unpaired electrons, right? So for this you should be memorizing the electronic configuration from scandium to zinc. Okay, I'll do this first question. This is important. You can see Z is 27, that means it is cobalt. Cobalt is 3d7 4s2. Now it is 2 plus, right? So cobalt 2 plus is 3d. Okay, I'll just make it 3 plus, or fine, 2 plus is also fine, 3d7. So if I draw 3d7, okay, 1 2 3 4 5 6 and 7, so number of unpaired electrons is 3, right? So what is the magnetic moment formula? 3 into 3 plus 2, that is root over of 15. You will get somewhere around 3.9 Bohr magneton. BM is also the units you should mention. Like that you can do the other questions. Next, interstitial compounds. I have already given. What are interstitial compounds? The compounds where there are some void spaces, and in that void spaces some atoms or elements occupy the space. And here are the properties why they have how they can improve the quality of the compounds. They become hard, they have more boiling point, chemically inert. Okay, next, they can, why transition elements can form complex compounds. These are the 3 reasons. Please revise them. Okay, Next, coming to coordination compounds, Werner's theory, very important question. Two types of valencies, primary valency and secondary valency. Primary valencies are satisfied by negative ions and are ionizable. Secondary valencies are satisfied by negative and neutral ions and are non-ionizable. Secondary valencies are used to find the coordination number and helps to find the structure of the compound. Okay. Next we have here applications. Basically this paragraph is very important. Which metal is present where, that you can find out. In chlorophyll we have magnesium, hemoglobin we have iron, vitamin B12 that is cobalamin we have cobalt. Next, geometrical isomers, this is important. You have facial and meridional, CO. So you can see here, one second, yes, if I draw, one second, yes, so I have, okay, so I have CO, okay, so if you take this one, N, N and N, okay, I am just writing in short, and this is NO2, NO2 and NO2, okay, so these are what, this is your facial, this is facial. For meridional what I can do, you have NH3, NH3 and NH3 and NO2, NO2 and NO2, okay. So this is your meridional. Now coming to here, cis and trans, PT, okay, NH3, NH3, Cl and Cl, and here we have PT, NH3, NH3, Cl and Cl. So this is cis and this is trans, okay. Next we have the definition. So ambidentate ligand, the definition example, heteroleptic and chelating ligands. Apart from that, you should also prepare homoleptic and the four type of ionization, isomerism, that is your linkage isomerism, okay, example and definition, coordination isomerism, example and definition, then you have solvate or hydrate isomerism, and then one more is there, right, ionization. So these four also, just read the definition and the examples quickly. Okay, next, synergic bond in metal carbonyls. So you know MC bond is your both sigma and pi bond. In sigma bond it is carbon to metal, and in pi bond it is metal to carbon, okay. Next, limitations of VBT and CFT. So especially VBT limitations is more important. You cannot explain the magnetic data, you cannot explain the color of the compounds, you cannot explain the geometry of the molecule. So these are the limitations. Here in CFT it is considered completely ionic, the covalent bond is not considered and ligands are assumed as point charges, okay. Next, you have d orbital splitting of octahedral and tetrahedral. Proper diagrams with these levelings are important. So please do this. The bottom leveling most of you forget. Do not do that. Next, hybridization. This is important. Like this, you can prepare for CO NH3 whole 6. Then you have CO Cl6 3 plus. Right. Then you have Ni Cl4 2 minus and Ni CN4 2 minus, okay. For all these four compounds you should be preparing the hybridization, magnetic and the geometry, okay. How will you write this one? Okay, next I have already explained. Coming to biomolecules, what are hormones, you should be knowing, hormones, functions, and this table is very important. So this can be asked in MCQs or in a 2-marker question, the different hormones and their functions, okay. Next we have one second, yes, this is also very important, the disaccharide structures. I know it is very difficult to remember, but yes, please give time and draw these structures 5 to 10 times, revise them and then go for the exam, okay. For maltose, sucrose and lactose, all of them are important. Amino acids, essential and examples. Similarly also prepare for non-essential and their examples, okay. Next, next is your reactions of glucose. To give you 6 carbon chain, you should react with Hi and red phosphorus. To give you carbonyl group, you should react with NH2OH. Then to produce that it has 5 OH groups, react with acetic anhydride, and for aldehyde group, react with bromine water, okay. Next we have denaturation of protein and which level remains intact during denaturation. So loss of biological activity is denaturation of protein, and then which structure remains intact, that is your primary structure. Okay, then these vitamins and their deficiency diseases revise. Okay, one more thing that I want to tell you here is difference between primary, secondary and tertiary and quaternary. A note on them please prepare. Okay, note on primary, secondary, tertiary, and difference between fibrous and globular. Okay, these two also revise properly. Next, coming to haloalkanes and haloarenes, prepare these name reactions. Okay, so I have given some of them. So this is your Fittig reaction, then you have Schwarz reaction for the preparation of alkyl fluoride, then you have Finkelstein reaction. So for example, if you have CH3Cl, react it with NaI and dry acetone, right, you will get CH3I. Now similarly you can prepare for Sandmeyer reaction as well. So all the name reactions I have a dedicated video, watch that. Then what is Setzeff rule? Major alkene product is formed, right? More substituted alkene product will be forming. The more substituted alkene is the major product. Okay. Next we have aryls. Aryl halides are less reactive, very important, resonance effect and sp2 hybridization of the carbon. SN1 mechanism, one example you should be seen, arrow marks should be shown properly. This is the slow step, this is the fast step, reversible, irreversible. Please match that. Then you have SN2 mechanism. Next, alcohols, phenols and ethers. So preparation of phenol from cumene. So isopropyl benzene plus oxygen, you will get this one, H plus H2, you will get phenol. Write it and then draw the reaction. Williamson ether synthesis, you have RX, okay, RCl plus R dash ONA, right, that will give me ROR dash plus NaCl. Okay. Next, Lucas reagent. So Lucas reagent, what is it? How will it help to distinguish between alcohols? So you know, tertiary alcohol will react immediately, right? Then secondary alcohol will react in 5 minutes, primary alcohol will not react. Okay. Next we have orthonitrophenol is steam volatile. Why? Because it is intramolecular hydrogen bonding. Paranitrophenol is having intermolecular hydrogen bonding. Then you have here steam distillation method, we can separate them. Coles reaction, the definition and the mechanism. Similarly, Riemer-Tiemann reaction, definition and the mechanism. Then 3 mechanisms from this chapter, that is your hydration of alkenes and dehydration of alcohols and preparation of ethers. Prepare also preparation of ethers. Okay. Next we have aldehydes, ketones and carboxylic acid. So between methanol and ethanol, which will undergo aldol condensation? Ethanol. Why? Because it is having what? Alpha hydrogen, right? Then although phenoxide ion is more stable, but it is less acidic. So the first reason here is in carboxylate ion, you have equivalent resonating structures and the negative charge is on the more electronegative atom, that is oxygen. In phenoxide ion, what happens? You have non-equivalent resonating structures and the negative charges in on carbon atom, which is less electronegative. Okay. Next you have here, that is one second, propane nitrile with phenyl magnesium bromide, that you can write down the reaction. Propane nitrile, CH3 CH2 C triple bond N, and then you have PH MgBr, right? Then you will have CH3 CH2 C. Here I will get here I will get pH and here I will get NMgBr. Then if I do hydrolysis, this one will get converted to CH3 CH2 CPH double bond O. Then HVZ reaction, very important one, please prepare it. Mechanism of addition of CN. Now aromatic carboxylic acid do not undergo Friedel-Crafts because carboxylic acid deactivates the ring. Next here, these are the list of the name reactions, very important. Rosenmond, Steffen, Itard, Clemenson, Wolf-Keshner, aldol, Cannizzaro, haloform, Riemer-Tiemann, Gattermann, Koch. Then HVZ, haloform, decarboxylation and Tollenson Felling-Stitch. These name reactions, just go through it. Next, last chapter, amines, how to distinguish between the sulfonyl chloride, right? Primary will react and give you a salt which is soluble, secondary will react and give you a salt which is not soluble, and tertiary will not react at all. Next, preparation of benzene, para-hydroxyazobenzene, Gabriel thalamide, complete mechanism. This is very, very important question. And then we have Hoffman bromamide degradation. Okay, so you will get amides reacting with bromine and KOH. Your primary amines will be produced with one carbon less than the amide, and these are the name reactions from this chapter that you have to go through it. Okay, so yes students, these are the most important things. So please go now and revise these all topics quickly, and then you are ready for the exam. Do not worry, all the very best. Trust your preparation, trust yourself, have full confidence, and I know all of you will come with flying colors in this exam. All the very best students, and I wish we will meet after the exam and you all are happy with your performance.